Hi there, and welcome to a Scratch tutorial. In this video, we will be adding 3D sound and object physics to our engine. By the end of the last video, we had basic player physics and collisions. We are well on our way to having a fully functioning engine. Adding object physics and 3D sound will really expand what's possible in this engine, giving us a more interactive world. Since we already have a player physics system, it won't be too hard to add object physics. We'll start by making 7 new variables, all for this sprite only. Object X speed, Object Y speed, Object Z speed, Object X dimension, Object Y dimension, Object Z dimension, and Object type. The speed variables will function as they did in the player sprite. However, the dimension variables are a new concept here. In our engine, an object is stored as a single point in 3D space. However, for collisions, it should have height, width, and depth. This is what the dimension variables represent. To initialize all of these variables, we will create a new add-object custom block that takes inputs for position, speed, and dimensions. We'll also edit the original add-object custom block to show that objects created with this block will not have physics. Now let's initialize the variables in the custom block. Finally, we'll use the new object type variable. In the add object with physics script, object type will be set to physics. In the add object with no physics script, object type will be set to static. Now that we can add objects, we can move on to coding the actual physics. We'll start by making a custom block called object physics with inputs for friction, gravity, drag, and bounce. We can use the player physics in the camera sprite as a guide. First, we'll change the Y speed by the gravity, then we'll multiply all the speeds by drag to add air resistance. This is the first major change in the object script compared to the player script. See, this friction technique works well to simulate player walking since it allows the player to quickly speed up and slow down. However, it is not accurate for simulating two surfaces sliding against each other. The current player script is similar to drag, or air resistance. The faster you go, the more it pushes back. When pushing something across a surface, on the other hand, the friction pushes back with the same force no matter how fast you go. This type of friction is called kinetic friction, and we will attempt to simulate it in our engine. But first, we need to add a bit more code. We'll keep the drag times speed code to simulate minimal air resistance. Now we can change the object position variables by the object speed variables. At this point, we have no collisions, but we can still test the basic physics. Before we can test, we need to add the physics custom block to the frame script. We'll start by creating a new if statement. If object type equals physics, the physics script will run. Now we can add it to our frame script. Finally, we need to fill in the inputs. We haven't added friction or bounce yet, so we'll leave those blank for now. For gravity, we'll use -1 to keep it consistent with the player's gravity. For drag, let's use 0.99 to add a very small amount of air resistance. If we want to test the physics script, we have to add some objects with physics. Let's start with a when key press block and set the input to E. If isClone equals 0, that is, if this is the base sprite and not a clone, we'll add a new object with physics. For the position inputs, we can use the camera position variables to create the new object at the camera. For the dimensions inputs, we'll take a look at the costume we are using. The cat costume has a width of 62 pixels and a height of 65 pixels. We can use 62 for the X and Z inputs and 65 for the Y input. Finally, we can use the camera direction sine and cosine variables to set the speed so that the object will move in the direction we are looking. When we test the script, we can press E to throw an object. So far, the physics system seems to be working, but as expected, there are no collisions, so the cats fall right through the ground. Before we can add collisions, this test reveals a bug that we should fix. Sometimes when we throw a cat, it blinks in and out, and sometimes it doesn't even show at all. This is caused by our 3D projection script and how Scratch rounds numbers. When an object is horizontally in the center of the screen and its screen x variable is a really small number like 0.0001, it tries to go to that position, but Scratch rounds the actual position to 0. When this script compares the position that the clone is supposed to be at with the actual position, they are not equal, so the script hides the sprite because it thinks it's stuck on the edge of the screen. To fix this, we can add round blocks to round all values to the nearest whole number. When we test it, we find that the bug has been fixed. With that out of the way, we can start adding collisions. The first step for collisions is creating a script to check if an object's position is overlapping with a hitbox. Again, we can use a similar script in the camera sprite as a guide. Overall, the script is mostly the same, except where the player only has height, an object has height, length, and width. Now we can add collisions to the physics script. We'll add our check for solid hitbox custom block after each change position block. If a hitbox is detected, we'll change back to the previous position and update the corresponding speed variable. Here is where the bounce input comes in. If the input is between 0 and -1, the object will bounce back. If the input is between 0 and 1, it will stop without bouncing back. Finally, we need to add friction. This will be applied when the object touches the ground, a vertical collision, so we'll put it in the Y collision if block. Let's think about how to approach this. The friction takes away a set amount from the total horizontal speed. To find this speed, we can use the Pythagorean theorem on the x and z speeds. To store this value, we'll make a new variable and call it speed. If the speed is less than the friction, the object should stop horizontal movement. If not, if the speed is greater than the friction, we should decrease the x and z speed. To figure out just how much it should slow down, let's look at a visual. Here's a diagram of the speed. If we move the z speed over to the left, we have a right triangle. If we add another triangle with the same angles representing friction, we now have two similar right triangles. Using our knowledge of similar right triangles, we know that the ratio of corresponding sides is the same. We can use this to set up an equation where total friction divided by total speed equals x friction divided by x speed. We can then multiply both sides by x speed to get x speed times total friction divided by total speed equals x friction. We can then subtract the x friction from the x speed to get the final x speed after the friction has been applied. This also applies to the z speed. Now that we figured out the math, we can put it in our code. Finally, we need to update the inputs on the physics custom block in the frame script. For friction, we'll try 2. This will slow down the object's speed by 2 units every frame. For bounce, let's try -0.7. Since -0.7 is less than 0, this should give us a pretty good bounce. Success! When we test the script, we can press E to throw objects that bounce around the 3D world. Now that we have objects that move around the world, the next step is having them produce sound that pans left and right depending on where it is, and fades away depending on how far it is. To start, The Scratch pan block takes input from -100 to 100. If we divide x by distance, we get an output that ranges from -1 to 1. We just need to multiply by 100 to expand the output to -100 to 100, and then we can use it for the pan block. We'll again use the Pythagorean theorem to get the distance. Next, we need to set the volume block. Here, we'll use something called the inverse square law. Basically, this means that the intensity of sound is proportional to 1 over distance squared. We're going to make a small tweak to this equation. Right now, 1 over distance squared causes the sound to fade out really quickly. If we change it to something like 5 million over distance squared, nearby sounds will be a lot louder. Now we can code this equation. Ideally, we'd put pan and volume in a 3D sound custom block and put the custom block in the frame script, but this will cause some problems. When we try to do this, the objects are no longer sorted. This is because the sound effect and volume blocks stop the script for a full frame, preventing the sorting algorithm from running. To fix this, we have to put the two sound blocks in their own frame scripts. When we test the project now, the objects are sorted. Finally, let's add some sound effects to the physics script to test our 3D sound. If a collision happens with a high enough speed, we'll play the tennis hit sound from the Scratch audio library. Now let's test it. And there we are! You may need headphones to notice the sound panning, but the fading clearly works, and we have successfully added 3D sound to our engine. Thanks for watching! We will definitely cover topics like moving platforms and camera tilting in later videos, and if there are other topics you want covered in this series, be sure to let me know in the comments. If you enjoyed this video, please like and subscribe, and I hope to see you in the next one.